Okay, now in this example, we're going to calculate the regular payment, calculate the M. As you know, we're always looking for an equation, and if we think back to the example that we did in the previous video, at this stage here, I do have a value, or an expression at least, with M in it. I will probably know how much was borrowed, the rate, the time, etc. And I guess you're thinking, but we don't have this amount here. And that's true. The most common situation where you'll be asked what the payment has to be will be such that this amount is 0. And the way that they'll present that, they'll say in order to pay off the loan in a certain amount of time. Now, if we're paying off the loan, remember that these amounts were the amount owing after a payment. If we've paid off the loan, the amount owing we want to be 0. Okay, let's get back to here. Sienna takes out a loan, $10,000 to buy a car. She'll pay the loan in 5 years, paying 60 equal monthly instalments. Beginning 1 month after taking out the loan, interest is charged at 6% per annum compounded monthly. Calculate her monthly repayment. Let M be the monthly repayment. We're used to that. R per month. Now, this is one where we have to do a little bit of adjusting of the R. So convert it to a decimal and divide it by 12. So we're getting a monthly rate. And that works out to be this nice decimal, which will be lovely in our 1 plus R will become 1 plus 0.005, which is simply 1.005. So where you see 1.005, it is replacing 1 plus R. So to find the amount owing, which we saw in the previous example, it's necessary to consider the interest that will be charged on the previous balance minus the repayment. So the amount owing after 1 month would be, this is P times 1 plus R, and of course it's only that amount, $10,000, will only sit there for 1 month, so the interest is only charged for 1 month, and so we get this amount owing. Strictly speaking, that is, for an instant, how much is owing. However, at the same time, a payment gets made, and so we need to subtract that amount. Now, you can probably see that it's really important that your payment is bigger than your interest. This M should always be bigger than however much was added on due to the interest. Otherwise, you will never get the loan repaid. Ask me more about that. Ask me to explain that if you don't get that concept in class. The amount owing after 2 months would be A1. I've simplified it here a little bit. A1, because that just stands for the same P, the amount owing, times 1 plus R. And A1 is, remember, this amount, and you'll see in a moment this has been substituted for A1. So it's the interest charged on A1 plus A1 and minus another payment. So we're staying A2. We need to replace this A1 with this expression, which you can see is happening here. If I underline this, then you can see that exact same thing written here, because it's just replacing this A1. And so we've still kept the 105 from there and the minus M. Now, you can see that I have multiplied the square bracket by the 1.005 to get this amount. You can see, hopefully, then I've taken this and I'm keeping it. Whoops, I'm keeping that. And that's sitting here. Why? Because 10,000 is the amount of the loan. 1.005 is our 1 plus r, and 2 the power is the same as the number of payments. I've then taken m outside of this and I'm setting up my GP. So you'll see in a moment that, or eventually we'll start swapping that around. The amount owing after 3 months would be a 2 lots of 1.05 minus m. Okay, you'll see that I've put in this little dotted line to show you that I'm going to replace A2, but I'm not replacing it with the direct line above. I'm going back one, just so that it'll make the expansion or multiplication by this term a little bit easier to see where terms are coming from. So, the rest of that line has been set up, and let's do the multiplication by this into that square bracket. So it becomes 10,000, 1.005 cubed. Multiplying this term, we'll end up with the square. Multiplying this, we end up with 1 lot, and of course on the end we've got our minus m. Now, we're going to separate this from the actual GP, because we quite like that term. You will see some explanations in textbooks, online, other places, even other teachers, where they include this term in their GP. I'm going to rewrite it as taking this m out first, and then this one, and the first one there. And you can see we're developing a GP. What that does then is allows us to set up or hopefully recognise the pattern, see what's going on, and set up, using that pattern, now an expression for A60. So we know it'll be the amount of the loan, 1.005 to the 60 minus m times. This series is going to continue, and remember there are 3 terms, and to the power 3, to the power 2, 3 terms to the power 2 when it was A3. So we will have 60 terms, but to the power 59. But remember, there are 60 terms there. Same line below there, to the power 59. And A60, what do we know we want this value here to be? We want that value to be $0. And so we've got this equation. What's happened between this line and this line is that all of this has been picked up and taken to the left-hand side, and it becomes a positive. And it's equal to our 10,000, 1.005 to the 60. This term stays. We're now just going about solving the equation. We've got a single expression for this sum. It is a GP, and its sum can be found using this formula. Maths is all about equations and formulas, where A is 1, R is 1.005, N, there were 60 terms, remember, minus 1, all over r minus 1, which is 1.005 minus 1, it's 0.005. So if I've got m times that, I'll want to divide both sides by this, which I don't need that first one. Divide both sides by 1.005 to the 60 minus 1 over 0.005. And the rule for dividing by a fraction is invert or turn upside down and multiply. 1.005 to the 60 minus 1. And when you go to your calculator, you get the 193.328, etc. You can take your calculator, and I'm almost assuming you have, and work that out as well. I'll do the HSC question with you in class, and if you are able, you might try question 2 from 7D.